In this video, I want to look at defining both ratios and proportions. So I'm going to start with the definition of a ratio. The idea of a ratio allows us to describe mathematically certain qualities or quantities that are mixed, combined, or related. Some examples, we can be looking at things like the flavor of a juice mixture, the color of a paint, or something like that. There may be small amounts or large amounts of the substances that we need to combine, but the idea is that we should always combine them in the same ratio. And there are a few different ways we can denote ratios. We might write it as something like 3:2:5. We might use colons, this is read 3:5. And sometimes we can write it in fraction notation. However, I'm going to delay using this fraction notation because fractions and ratios have very different meanings. And later I'll look at how to connect these two. Next, I want to define a proportional relationship. A proportional relationship is a relationship between two quantities where all the coordinated pairs of values are in the same ratio. So whenever we're looking at ratios, we can think of if we have a table or something of equivalent ratios, then that would be a proportional relationship. We can think of pairs of quantities in a proportional relationship as kind of varying together. If a person were to walk 5 meters every 2 seconds, then their walking time would be proportional. They would do 10 meters in 4 seconds, 15 meters in 6 seconds, etc. So this is the idea of a proportional relationship. And proportional relationships are really important because they help build the groundwork for understanding later concepts such as slope, rate of change, and linear functions. Now that we have the idea of a proportional relationship, let's define a proportion. A proportion is a statement that two pairs of amounts are in the same ratio. As an example, we can say 14 cups of flour and 4 cups of milk are in the same ratio as 7 cups of flour and 2 cups of milk. Defining it like this, we can also describe proportions in terms of equivalent ratios. So if two pairs of amounts are in the same ratio, then we say that the ratio that each pair specifies are equivalent. So, as an example here, 14:4 is equivalent to 7:2. Equivalently, we often describe these as equivalent fractions as well, saying 14:4 is equivalent to 7:2. There may also be times that we want to solve a proportion. So we know if we have 7 cups of flour, it's in a ratio of 2 cups to milk. And we know we have 21 cups of flour, but we're not sure how much milk we need. Equivalently, we could write this as 7:2 is equal to 21 to x. So we're trying to figure out what that value of x is. And this process of finding an unknown value in a proportion is called solving a proportion. And in our next lesson, we will look at how to properly solve proportions and how to think about these.